Welcome to The Explainer. Today, we're taking a look at one of mathematics' most famous puzzles, but through a completely different lens. For almost 100 years, the Collatz conjecture has been this fascinating curiosity. I mean, it's a problem so simple you could explain it to a kid, yet it's so profound that the world's best mathematicians have completely hit a wall trying to solve it. But the source material we're digging into today asks a pretty radical question. What if this isn't a puzzle at all, but actually a blueprint? The theory it proposes is that the conjecture describes a universal pattern, one that connects everything from the way a tree grows to the fundamental laws of physics. Okay, so let's dive right in. First things first, what exactly is the Collatz conjecture? For anyone who needs a quick refresher, the rules are incredibly simple. You start with any whole number you can think of. Seriously, any one. If it's an even number, you just cut it in half. If it's odd, you triple it and add 1. And then you just keep applying those two rules over and over again to whatever new number you get. And here's the real mystery. Every single number that's ever been tested, and we're talking numbers into the quintillions, eventually falls into this simple repeating loop. 4, then 2, then 1, and right back to 4. But it's at this exact point that our source material takes a very sharp turn. So instead of seeing these sequences as just lines of numbers, all heading towards 1, our source suggests we look at them in a totally different way, as a living, growing structure, something like a tree. This framework proposes this amazing analogy from biology. The even rule, dividing by 2, is like gravitropism, that downward pull that sends a tree's roots deep into the dark, unseen earth. The odd rule, 3n plus 1, is compared to phototropism, that upward surge as the branches reach for visible light. And the source anchors this entire metaphor in a verse from the Quran, which you can see right here. In this view, the conjecture stops being just a math problem and becomes a kind of mathematical description of this good tree, a structure that connects the hidden world of roots with the visible world of branches. So in this model, reaching the number 1 isn't the end of the journey, not at all. It's actually a return to the trunk, the origin from which all these numerical branches and roots grow. Each sequence is just a different path back to the source. Now, this tree metaphor is built on what the source calls the 2-3-7 blueprint. You can think of it as a proposed 3-part engine that's driving this whole process. It all begins with the number 2. Within this framework, which actually draws its terminology from Arabic, this represents the split, or razim. It's that fundamental duality we saw in the tree metaphor. Up and down, seen and unseen. Next up is 3, which the source labels the formation, or rahim. This is presented as the principle that gives that initial split a path and a structure. It's the engine that gives it direction. And finally, we have 7. This represents the complete cycle, which is termed the return, or Raman. It's interpreted as the guarantee that the whole system is a closed loop, where every path always resolves back to unity. This table here really lays out the whole mapping. As you can see, the simple Collatz rules are reinterpreted as what the source calls DCU operators, the split, formation, and return, which are said to operate in these conceptual fields of light, sound, and throne. Now, this is where the theory takes another really big leap. How does this abstract blueprint apply to the physical world we actually see around us? Well, the argument is that it's the hidden algorithm behind physics itself. I mean, get this, the framework even draws an analogy to the fundamental operations of calculus. The derivative, which splits a function to measure change, is compared to the split. The limit, which finds an exact law, is likened to the formation. And the integral, which sums everything back up again, is seen as the return. So what this suggests, according to the source, is that the conservation laws of physics might follow a similar deep logic. The same principle that ensures energy is only transformed, not created or destroyed, is argued to be the very same one that's driving the Collatz sequence. And this all culminates in a single master equation, which the source material proposes as the actual operating system for reality itself. It takes the form of a cubic function, an equation that's often used to model complex dynamic systems. But in this interpretation, each and every term is assigned a specific, fundamental role in nature's processes. This slide is great because it shows how the source translates this abstract math into observable actions. So the ax cubed term, the split, is like a tree branching out. The bx squared term, the curve, is like an apple forming on a branch. The direction is a river finding its path, and the return is a planet's stable orbit. And this brings us right back to where we started, the end of the Collatz sequence, that simple 4-2-1 loop, and what it all ultimately means within this framework. If we look at that final inevitable loop, 4-2-1, and we just sum those numbers, we get 7. And according to the source, this number is no accident. It's seen as the signature of the entire system. So the key idea here is that 7 isn't just a number. It's presented as the seal of conservation, a kind of mathematical proof that the system perfectly preserves and balances itself. It's meant to show that no matter the path, nothing is lost, and that equilibrium, which the source calls mizan, or perfect balance, is always restored. And that's why this interpretation, whether you see it as a key or just a curiosity, is so worth exploring. It challenges us to look for connections in really unexpected places, to see the world not just as a collection of separate fields, but maybe, just maybe, as a system that might be described by a single, integrated story.